All right, so we are on 844, if I can get the pen to work, maybe. There we go. All right. So on number 10, here's what, and we talked yesterday about the ability that even though it says x plus pi, we hadn't been playing with radians on the shifts yet. So we said, okay, like we said, one last fling with degrees. We'll call it plus 180. So when I got here, I knew two things right away. I knew my amplitude was changing to 3, because again, that's my coefficient that I'm working with in here. And then I also knew with the plus 180 that I was shifting left 180 degrees. So when I went to create my table, since we're in degree mode, normally our base graph with degrees, like we had mentioned before, okay, now here it's all in pi, that's what we're heading to, but since we're on our last fling, we didn't have any change in period, so it's still 2 pi, or 360 degrees in this case. However, I am taking that degree measure, and this told me that I was shifting it left 180 degrees. So I'm going to subtract 180 degrees from this. So I'm just going to take my degree and minus 180. And yes, you can absolutely go into the negatives. Okay? Sine and cosine curves go infinitely in both directions, so it's not like there's a certain limit to them. So I minus 180 from each of those. Okay, that'll get me my new actual degree measures that I'm going to be using. And since I'm using sine, sine's values aren't changing at all. So my values are 0, 1, 0, -1, and 0. Okay, once I get here, I don't need those initial degrees anymore. I just had them there to have a reference point. And at this point then, when I go to make my chart, oh, let's see. We'll do every 2 being 90 degrees here. Now I'm just going to put in some extras. And then we're at -90 and -180 here. And since my amplitude, which nobody called me out on, dang. Yeah, I was going to say, what's up with my current values that I have?
0, 3, 0.
I could. If some of you are still getting used to the whole thing with your degree measures and the values that go with them, having an extra column in this case, if you wanted to take your value times 3, wouldn't be a bad idea. Now they're all nice and red. So I'd be, okay, at -180 I'm at 0. At -90 I'm at 3. At 0 I'm at 0. At 90 I'm at -3. And at 180 I'm at 0. And again, all you're required is to do one period. If you were asked to do multiple periods sometime, you would just keep the same pattern going. And it was mentioned earlier today, well, all these curves look the same. Yeah, except if you have, a stretch or a shrinkage with this, yeah, a lot of them are going to look the same. That's absolutely true. But that's how that would look when we're playing in degree mode. Okay. Now, the additional challenge that comes now today is not only are we going to have the shifts, but now we got to keep dealing with the mental thought of dealing with these fractional things that have pi, these radians. Not a bad thing, but you've got to get to a point where you figure out, how am I going to deal with it? So I'm going to try a couple of ways today to make it easier to deal with. That's kind of our goal. So, okay. Au revoir, degrees. It's been great. When we actually get to them, yes. Because we're going to start doing a bunch of radian things now. So that should help on those too.
Or you just start on the whole thing?
No. because let's see, you have 3 left there. So yeah, probably. So
We didn't do radians.
no, we have not done radians at all yet. Yeah, I just put all the answers up so when we get done with the notes today, if people were starting to work on a couple and wanted to see if their answers were going okay, I just wanted them up for that. So yeah, no expectation that you have done 32, 33, or 39 off the homework yet. So okay, let's play with radians. Couple of basic things to look at. Okay. First thing here, thank you, is I notice there's no change in my period. There's no value in front of theta or out here. Okay, so my period, since we now only talk in radian, is 2 pi. Okay, so we've got that part, and that's going to be our base that we're working with. So that's nothing too bad. So then my next chore comes up. What does this minus pi over 2 tell me? Okay, we're going to be heading to the right with a shift, pi over 2. Now, you're allowed to think in degrees if that helps you. Pi over 2 would be 180 over 2, which is 90, but we no longer speak it. We do not write it, okay? If you have to, we'll do it off to the side somewhere so nobody knows, okay? Otherwise, when we come up and start working with this, okay, so my radian measures, my period hasn't changed. So again, those of you that think in degree mode, those of you that are still thinking and just going back and going, oh, it was so nice when they were just numbers, okay? That time has come and gone. So we're at 0, 90, remember, pi is 180. So some of you have come up with this neat little trick. You're like, well, okay, I'll do the ones that I know. Pi is 180. 360 is twice as big as 180, so it's 2 pi. Now my only job is, since there's equal spacing between every quarter point, I just have to find what's in the middle. So what would be in the middle between 0 and pi? Pi over 2, because I also can think, well, it's 90. 180 divided by 90 is, excuse me, 180 divided by 2 is 90.
That's the only one I guess is the one.
This one, okay. 3 pi over 2. Now here's a couple of ways you can think about this to make this a little easier. Because we were talking earlier, what are some ways that people were thinking of that they could do this? And here's the 2 things that got brought up. I had somebody say, well, here's how I think of it. I think of it as the first one, 0 over pi. I'm like 0 pi. 0 pi. I gotta speak their way. 0 pi. I'm like, okay. 2 pi is 2 pi. I'm like, okay, I see what you're going with. Well, this pi over 2. I'm like, okay, so 1 pi over 2. I'm with you. Well, then the next one's just 2 pi over 2, because 2 divided by 2 is 1. It's 1 pi. I'm like, okay. Well, if I'm going up by 1 each time, the next one's got to be 3 pi over 2, because it went from 0 to 1 to 2 to 3. And then this is 4 pi over 2, which reduces to 2 pi. I'm like, that's really sensible, okay? You found a pattern. It's just going up by 1 each time. So then I kind of chuckled at this, but it made sense. Somebody else said, well, I think of it like money. I'm like, okay, how are you going to think of this like money? Well, I got no money. Okay. Well, here I got $1 because I have one of it. All right. Well, what's in between nothing and $1? 50 cents. A half dollar. They're thinking of pi like it's $1. I'm like, okay, I'm with you on this. Well, if this is $2 and this is $1, what's in the middle? $1.50. Oh, 3 over 2 is 1.5. It's 1.5. So I'm like, okay, those are the little type things that you've got to kind of wrap your mind around with this. But again, if you need to think back to degrees, you can, okay? If you get to this one and you're stuck, and you're sitting there going, well, this used to be 270. So 270 times pi over 180. I'll just quietly do it here. 270 pi over 180. 270 over 180 reduces to 3 over 2. And now I'm talking in the right language so I don't get in trouble. Well, now my period itself isn't changing. The only thing that's changing is I'm going to be shifting my graph. I'm moving it horizontally. So
like, what if there's one in between 90 and 180?
So like if there ends up being a period change,
Yeah.
we're getting to one of those coming up really soon. And we'll talk about how we can even deal with that with either of those ways that I just talked about.
Why do 2 pi is just the regular period, right?
Yes, this period is not moving.
Okay,
Yeah, this particular one, we'll get to some that the period moves, but in this one it doesn't. And that's why I went ahead and I still wrote the period, just so we're used to it.
because there's like B.
Right, because there's nothing in front of here. There's no B value that I see that's changing. Right. So here, I'm going to take my radian value, and I'm going to subtract, not subtract, add. We're not to the values at the end yet because we still have to shift. Right, yeah. Because since I'm going right, okay, I'm going to be adding this pi over 2. You're like, but that says minus. Remember, my shifts are opposites. So I start to look, and I'm like, okay, I'm shifting right 2. What's 0 plus pi over 2? Pi over 2. Okay, let's do the easy ones first, and then we'll figure out how to deal with the others. Pi over 2 plus pi over 2. Okay, let's think about it this way. 1/2 plus 1/2. 1 whole. Pi. Okay, let's think about it. If I have pi over 2 plus pi over 2, think of it like you would a fraction. I have a common denominator. The denominator stays the same. 1 pi plus another 1 pi is 2 pi, and 2 pi over 2, the 2's cancel, and I'm just left with 1. It's like working with a regular fraction. I think some of you are seeing that pi, and you're thinking it changes rules of fractions. It doesn't. All I'm going to do is take what I have and add another pi over 2 to it. So for instance,
Keep going.
okay, so here, again, let's stick with the simple ones.
Is it 2 pi?
One of them will be. So if I'm here, I'm like, okay, I've got pi, and I'm adding another one. So if I have 1, and I add another half, it's 1 1/2, right? What's 1 1/2 fractionally as an improper? 3 pi over 2. Notice the pattern that's starting to develop. I have pi over 2. This, if I added 1 to it, would be 2 pi over 2, but I just reduced the fraction. The next one's 3 pi over 2. Do you see the pattern starting to develop? Okay, 4 pi over 2, but what's that reduced to? 2 pi, because 4 divided by 2 is 2. And the last one's 5 pi over 2. Now again, whether you find a pattern like this and work with it, or again, when we started to talk about the possible money idea before, it works. Okay, I got nothing, and I add 50 cents. Okay, now I got 50 cents, or I got a half a dollar. If I have a $1/2 plus another $1/2, I have a whole dollar. If I have a dollar plus a $1/2, okay, I know we'd say 1 1/2. We wouldn't say 3/2 dollars. But again, if I got a $1.50 and I had 50 cents, I got $2. $2 plus a half gives me $2.50. Just keep telling yourself the pi gets treated like, you know, it's not even there, like it's an x value, and that'll help on this, because I think that's the thing that's probably getting most of you the most on this. Because then, when I get to my value at the end, okay, I didn't have an amplitude change. So since it's sine, just like before, my sine values don't change at all. Okay? The only time these will change is if I have an A value, if there's an amplitude change. So, I don't need these guys anymore. I just had them there to help me out. And now I just work my way through and I go, okay, so at pi over 2 I'm at 0. At pi, I'm at 1. At 3 pi over 2, I'm back down to 0. Down to negative 1. Did I just skip one? Did I do something silly? Yeah, I did. Silly man. I gotta watch where I'm making my dots. 2 pi is negative 1. Again, as long as you get through that cycle, you're good. So, that's what I've got to work with. And the thing that's tricky is it's still the same period, okay? It's still a full 2 pi, but we're just so used to seeing the first value being 0 and the last value being whatever the period is, it kind of messes with us a bit. And that's why I wanted to put it in the original base format first so I could see what's going on. So let's do one more kind of back this way, and then we'll kind of start adding some pieces to it. Okay. No period change. Period is still 2 pi. What's my shift going to be? Right, pi over 4, or right, 45 degrees. So I take a peek, and I say, okay. Again, my regular old radical way of doing things. Here's what I'm always starting with. But now, oh gracious, call out the police. This is going to be a problem. I need to add pi over 4 to each of these. You're like, but wait a minute. Everything we have doesn't have a fraction and says pi over 2. What the heck am I supposed to do now? Okay, we make an adjustment. Our common denominator now is going to be 4. So let's think about this for a second. This still would be 0 pi over 4. Okay, that's not a big deal. Pi over 2. Now let's think about this. Okay, I'm not going to add to it yet. I'm trying to get some of you into a thought process. Some of you are ready to roll already, because that's right. What do you multiply 2 by to get to 4? 2. So that pi becomes, okay, 2 pi over 4. I just want you to see the pattern before I start filling this in. Okay, if this is pi, or pi over 1. 1 times 4 is 4. Now, before I start doing all of this with any of the rest, what are the last two going to be? Okay, 6 pi over 4 and 8 pi over 4. What I did was I took a minute to think about it and get a common denominator, because now when I go to fill in my chart, I'm just going to add one more to it. So if I have 0 pi and I add 1, now I have 1 pi over 4. If I had 2 of them before and I add another 1, now I have 3 pi over 4. If I had 4 and I add 1, I have 5.
Wait, why are you adding 1? I thought you were...
I'm shifting right pi over 4.
Oh, and you already did the denominator.
And I already did the denominator stuff here. And now I'm just adding it.
Why wouldn't you add the 2 pi?
Why wouldn't I add 2 pi each time?
Yeah, I thought you were...
Okay, this is just making a common denominator out of these. This is kind of sliding into here and becoming my radian degree. I just keep looking at that kind of as a reference. And what I'd even consider doing is just keeping the base ones on like a note card or something in front of me, and literally when I went to fill in this column, making it look like this instead, so I could see right away, okay, here's all of my regular radian measures in the right denominator, and then I can add them over. Now some of you can look at this and say, this is 1/2 plus 1/4, it's 3/4. Awesome, go with it. Or 1 plus 1/4 is 5/4. Or 3/2 plus 1/4 is 7/4. If you can do that mental math with that, do it, okay? But if you need to make a common denominator, there's nothing wrong with that. Because once I have that set, This time I'm dealing with cosine. So my values are going to take on the same values that a base cosine graph does. And then I just get rid of my old radians and look at my shift. Now you're like, but wait a minute, I don't see these values anywhere on here. Well, remember, these being in the middle, this is my pi over 4. This is my 3 pi over 4. This is my 5 pi and my 7 pi and my 9 pi over 4. The advantage you have when you draw your own graphs is you can just write these and not have to really think about it. So when I go to graph mine at pi over 4 right here, my value is going to be 1. Okay, my next line here, my 3 pi over 4, I'm at 0. At 5 pi over 4, I'm at negative 1. And I just keep working my way through. And again, as long as you get that first period, we're good. But you've got to be able to deal with the fractional portion of things. So again, it's like learning a foreign language. It's tricky at first, and you think like somebody's talking, like you have no idea what they're talking about. But the longer you immerse yourself in it, the easier it gets. Okay, are we kind of starting to see how we're going to have to deal with this fractional stuff? Just like dealing with regular fractions. So some of you that hate fractions, we're going to have to overcome. They're like, oh boy, and now he's going to add something. One piece. I'm going to add one piece. We're going to scooch up here. All right. Now we get into period changes. Because now I see a value in front of theta. This gets moved to the outside. So here's how this works. So y equals sine 2 theta minus. Now, before some of you panic here and go, oh my gosh, what do I put in there? Think about what you just did. 2 times theta is 2 theta. If you divide this by 2, that's where the theta came from. So this is 1/2. So think for a minute. What's half of 1/2? Okay, a quarter. Half of $1/2 is a quarter. So this is going to be pi over 4. You're like, now wait a minute. Where's that coming from again? Okay, if I distribute out, I get 2 theta. 2 times pi is 2 pi. Over 4 would reduce to this. You're doing the distributive property backwards. So instead of multiplying when you pull it out, you're actually dividing by that value. So I just divided each of these by 2. And if you have a fraction like 1/2 and you divide it by 2, remember that's the same thing as multiplying by 1/2. So that's where this 1/4 or this pi over 4 is coming from. Okay? But theta's always got to be by itself. So once I get there, I know 2 things now. My first thing I know is that my period, which normally is 2 pi, just got divided by 2, which means now it's pi. And I also know that I'm going to be shifting my graph right pi over 4. Okay, those 2 things are changing this time. Now we've done the shift left-right thing already, so that one I think we're okay on, but we'll see. So when I go to do my columns, I'm going to be cutting all of my degree measures for radians in half. So let's think about this for a second. Okay, here's my base degrees I'm doing. Cut them all in half. Well, cutting 0 in half doesn't do much for us now, does it? Do the simple ones first if you're not sure. What if I cut pi in half? Okay, I have half a pi. Pi over 2 in the middle. I'm just getting you to look for patterns. What's half of 2 pi? pi, okay? So do the whole numbers first. Then start thinking about just what's in the middle. What's in the middle of 0 and a half? Okay, 1/4, or pi over 4. What's in the middle of half and a whole? 3/4, or what's in the middle of 50 cents and a dollar? 75 cents, or 3/4 of a dollar. Don't let fractions intimidate you.
Can you pick up, please?
Oh, when we get to here, okay, so we've got our radian value. Yeah. Okay. Another easy answered question. So we're shifting right, so we're going to go plus pi over 4. So basically I'm adding 1/4 to all of the fractions. So add 1/4 to 0, I get 1/4, or pi over 4. 1/4 plus 1/4 is 1/2. 1/2 plus 1/4 is 3/4. And again, you'll start to see the pattern. 1 pi over 4, 2 pi over 4, but it reduces. 3 pi over 4, 4 pi over 4, or pi. And 5 pi over 4, or 1 plus 1/4. Still don't have anything with my amplitude. So my values all base on my trig function. And since it's sine, we get that set. We say goodbye to those. And we go, okay. So here, for instance, yeah, we did the period change. Because here, instead of going from 0 to 2 pi, we went from 0 to pi. So we took care of the period change right away with my radian values. Because basically we normally, remember, normally when I don't change my period at all, these are the values that my radians. The pi over 4 shifts whatever my initial radian value is. Whatever my base period is, this would be if I had a period of 2 pi. It would be these. When it went down to pi, it's half as much. So I divided each of these values that I have in my base by 2. So this is my actual single 1 period of pi, what my values would be before I shift them. So I write that part down first, dealing with my period, then I shift it. Because then when I get to here, now I'm ready right away with these, and I'm not having to get cute when I'm plotting my points. And making my curve. But whatever that value is that you pull out is what I'm having to do to tweak my shift, which is the biggest thing here. One last specific thing I want to discuss, and then if there's some other detail stuff we want to take care of, we absolutely can. I'm going to pop down to 11. So I want to make sure we get an up down in here too. So on 11, all right, what do we notice? No period change. So my period's going to be back to good old 2 pi. So with me knowing that, I'm going to go ahead, I'm going to get that in here first. So being back to good old 2 pi, I know how to set that up. But what is changing? What's moving this time? What's this guy out here doing for me? Okay, that's going to move me down 2. And this guy is going to move me left pi over 2. So I got 2 things I got to do to this one. I'm going to deal with my shift first. So here, we're going to take our radians, and we're going to subtract pi over 2. We're going to subtract a half from each of these. So negative pi over 2. We always like the first one. It's the easiest one to work with. Half minus a half. 0. 1 pi minus a half is positive pi over 2. Again, just think of it like whole numbers and fractions. 3 halves minus 1 half is 2 halves, otherwise known as pi. And 2 minus 1 half would be 3 halves. So it just went that way each time, down 1 half. But here's the one other thing I've got to watch for. Because now my values, okay, normally my values with a cosine, normally, I'm going to make them real small here in the corner, would be 1, 0, negative 1, 0, 1. But it's down 2. So I take my regular, my base value, and I'm going to minus 2 from each of them. So 1 minus 2 is negative 1. 0 minus 2 is negative 2. Negative 1 minus 2 is negative 3. 0 minus 2, we start heading back up. And 1 minus 2 is negative 1. So those would be my values that I was going to plot. So you're like, negative pi over 2, that's actually what this guy would be. So when I go to plot, negative 1 at negative pi over 2. At 0, I'm at negative 2. At pi over 2, I'm at negative 3. At pi, I am back to negative 2. And at 3 pi over 2, I am back to negative 1. So that's what the tackle is up to here. So reminders, just in case, I'm not going to make assumptions on anything anymore. I know where that's gotten me. Okay. We're going to have first check on this will be Monday. Tuesday will be the last full credit day. Yep. So
What about this sheet you made?
that's what I'm going to talk about here in just a second. Because I was looking at this and I'm like, there is no way in bleepity bleep. Okay? These are the 3 new problems from the bookwork. They're just like these. I'm like, 3 is not bringing this home. There is no way. So, I'll have answers up on Monday for these 3 problems graphed out, and I'll also have answers up for the graphs on that sheet you picked up. Okay. Worst case scenario, you should at least have written your periods and your shifts on that worksheet and tried a couple of them. There is no human possible way you come in Monday with none of those graphed, or you're going to get hammered on the quiz and I will not feel bad. And I even have that on tape now. So, we have about 20-25 minutes if we need on Monday to go over some stuff, but if you're getting stuck, you'll need to pop in before that quiz and we'll do some things, but we're not going to go forever on this.